Hello once again. In this video I will show to you how to measure a travel distance of a robot. We will draw a robot for a predefined distance, and we will going to use a while loop timing to determine the driving distance. So now open your lab view and go to the experiment 1 from the last video. We will use that so open your previous example. We will use that project as a template here. So open the VI, and here you can see the program we created last time. Open the block diagram, and we can see that we last time control motor speed and read it. Okay, now we are going to use elapsed time in order to measure a time between two loops of while loop, and we use that time to multiply by the speed and get the travel distance in one loop. So I will go to search and search for elapsed time. It's not this. Okay. So the tick count. Okay. We will use milliseconds. Okay. And we want to have here initial tick counter and one in while loop to measure milliseconds of while loop. So I will connect this to the while loop, and then we want to see a difference between a hold time and the time that elapsed in one loop. We'll go minus, and because we are working in milliseconds, we will divide it with 100. Okay, create constant 100, and that's the seconds. And we will just replace this with dBl numeric. So create, we'll go to numeric palette and dBl, because we want to have something that is different from whole number. We want to get a real number, so 1.2 seconds or something like that. Now we want to multiply the speed of wheels with this time and get the amount of distance that is traveled in one loop. Put this aside. Okay, just put that aside, and now multiply these two numbers. So going to multiply. Okay, and now multiply one speed and another with the elapsed time. And because this number can be positive or negative, and we want to integrate these values, we are going to use an absolute value. Also, we need to initialize the travel distance at the beginning on a 0, and we have here for one and another wheel. Just move this aside. Okay. And now we want to add this travel distance with the previous distance. Add one at here and one down there. Okay. And we want to pass this value out of the loop. Now we are going to use shift register in order to have this new value on the beginning of a next loop. That's it. And of course, we want to have this elapsed time in the next iteration also, and we're going to use also shift register to accomplish that. Now we can, in the same manner like here, show the traveled distance. I will just copy this here and go and connect distance of left and right wheel to waveform chart. Now here is the chart, double click on it, and I will set this distance from 0 to 100, and here again minus 100 to 100. Right click on it and just want to set no auto scale on epsilon. and no auto scale. And we need to add how much distance the robot should travel. We will going to use for that one dial, and it's going to be from 0 to 10 meters. In meters, okay. Now we need to add exit status. So if the distance of desired distance greater than this distance, the program should stop, and we will accomplish that. So like this, greater or equal, and we will ask if the travel distance greater or equal to desired distance, and just add one or sign here, connect with this, and now we are ready to start. So just one correction. We want to measure speed in radian per seconds. Or no, radian. We have speed in radians per seconds, and we want to have speed in meters per seconds, and we just search for radians per seconds. Radians per second to okay. We will copy this and name is per seconds to meters per seconds, and we will type here 0.392 3192 multiplied by x and divided by 2p. And for another wheel, same but with one minus. And we want now to connect this with calculating of speed. So okay, now we can go to our front panel, clear charts, and run a simulation. So now you see our robot is traveling, the distance is going up. We can go a little bit much speed on. You see the robot, distance is going more up. Now can set the speed to be a little lower. Road is slowing. The speed is slow and the distance is going up, but in small gradient. Now we can give our robot negative speed. He is going to go back, but the distance is integrates. And at 6 meters it will stop and the program. So that's it. That's for this video. You see how to drive robot for a predefined distance.